All right, today we're going to be talking about surface area, finding surface area of three-dimensional figures, and I think this might be review for some of us, but we are going to go into some tougher shapes. We're going to go through a few vocabulary words to start. Okay, a polyhedron is any solid that's formed by polygonal surfaces that enclose a single region of space. Okay, so anytime we have our polygons put together to form an enclosed shape, right, then we call that a polyhedron. Okay, so like a cube or a pyramid or a prism, all of those kind of shapes are kind of grouped with polyhedrons. Okay, here I have a couple of examples up on the board, okay, to show you that here we have a bunch of triangles put together. Okay, so this would also be a polyhedron. Here we have a couple pentagons put together. Okay, so kind of a variety of different shapes. Prisms. Okay, prisms, they are a polyhedron, as I mentioned in the previous slide, with two congruent parallel bases connected by a bunch of lateral faces that are parallelograms. Okay, so what that means here in this triangular prism, notice that we have two congruent parallel bases. We have two triangles here. Okay, they are parallel to each other, the top and the bottom of the box. Okay, they will never touch. Okay, so those would be the bases, and we wouldn't call our rectangles here, we would not call those the bases because they're not parallel to each other. Okay, same here with our rectangular prisms are kind of unique because you can kind of pick which of the rectangles are going to be your two congruent bases. Okay, in this case, we can kind of just assume the top and the bottom here will be our two bases. Okay, and prisms are always named by their base. Okay, so here we have a pentagonal prism, right, because their bases are pentagons. Okay, and down here we have a hexagonal prism because their base is a hexagon. So prisms are always named after their bases. Prisms are a little different. Okay, they're still in the polyhedron category, and they just have one base. Okay, and it's a polygon base and a triangular lateral faces. So if you look back here, our lateral faces were all rectangles. Okay, we had all rectangles in our prisms. Okay, all of these other ones that were not, they were all rectangles going here. Okay, whereas with our pyramids, their lateral faces that are not the base, those are always going to be triangles. Okay, so that's kind of a good tell. Also, a lot of people like to tell the difference between prisms and pyramids is that there's always like a pointed end, okay, or like a sharper end, whatever you want to think. Now again, just like prisms, pyramids are also named after their base. Okay, so here we have a rectangular pyramid, okay, or a hexagonal pyramid because it's a hexagon base. Okay, next, what is surface area? Okay, that is the sum of the areas of all the faces or all the surfaces of an enclosed solid. Okay, so here I have an example of a rectangular prism. Okay, and we would need to find the area of all the surfaces, and then we would add them all together. So we'd find the top, we do base times height, base times height, base times height to find the area of all of these pieces, and then we would add them all together in the end to find the total surface area. So kind of like wrapping paper, kind of anything you can touch on the outside of the shape would be considered the surface area of the shape. Bases, okay, a polygon or a circle used for reference to determine an altitude or other feature of the solid or to classify the solid. So we already talked about how they're named after their bases, so that's why they also include the classifying it. Okay, so a polygon or a circle used to reference to determine the altitude, kind of like the height of the figure. Okay, So we always kind of use our base as a form of reference when we're trying to solve surface area or volume. Okay, so here we have our cube, okay, and our cube obviously has a square base. Here our cone has a circle base. Cylinder also has a circle base, okay, and kind of some other unique shapes. Lateral faces. You probably heard me mention lateral faces just a little bit ago. That's a face of the polyhedron other than the base. So kind of like all the other sides that aren't considered the base in the shape. Okay, so for this we have a hexagonal prism. Okay, so our base would be these hexagons. Sorry, I keep messing that up. Okay, so our bases are our hexagons, so everything else is considered a lateral face. Okay, so all of these rectangles that you see here, we have a rectangle that connects our two bases going all the way around. Okay, we have 6 of them because we have a hexagon, so we're going to have 6 lateral faces here. Okay, and again, in a prism, they're always rectangles. Slant height. You will be using slant height a lot during this unit. Okay, slant height is the height of each triangular lateral face of a pyramid. Now, if we're trying to find surface area of a prism, we have to use the slant height to find the area of this rectangle or this triangle off to the side here. So this one going up on the side of the pyramid, we need to use that slant height. So here, let me draw it kind of two-dimensional here. We need to use the slant height to find base times height to find the surface area. We can't use the regular height of the pyramid. We have to use the slant height. Okay, so slant height is going to be important in our surface area unit and then in our volume unit coming up here in a couple weeks. All right, pyramids kind of have some not different features, but their vertex is kind of the only one that we haven't talked about yet. Okay, and that's where all of the lateral faces meet up at the top. So the vertex is always opposite of the base. Okay, and we have lateral faces are always triangles in a pyramid. Okay, and the lateral edge is just that edge of the face. Right? We don't really use lateral edge very often. Okay, and it's not the same thing as slant height. Slant height goes right through the middle of the triangle, whereas edge would kind of create the pieces of the triangle. All right, steps for finding surface area. Okay, draw and label each face of the solid as if you kind of cut them all apart. Okay, it's easier if they're laid flat on a surface in 2 dimensions, and then calculate the area of each face after you kind of laid them all out. Okay, if some of them are identical, you only need to find one and then times by 2 or times by 4 or times by 6. Okay, so you don't need to just add up every single one. If you have, let's say, a hexagonal prism, that means you're going to have close to 6 of the same rectangle. Okay, so you don't need to find it every single time. And then just add up all of those areas at the end. All right, so if we're getting started on our first one here, finding the surface area of this prism. Okay, so first, I like to just lay out all of my different pieces here. Okay, you can choose to do whatever you want. Okay, it's up to you. It's however you like to do it. Okay, and I'm first going to start with my front and the back piece. And I know that's going to be an 11 by 6, so 11 by 6, which ends up being 66. And then I'm going to have to multiply that by 2, right? Because I have 2 of them. And then here, my left and my right piece is a 5 by 6. 5 times 6, we end up with 30, which I'm going to have to multiply by 2. And then my top and my bottom, okay, I have 11 by 5. So 11 by 5, which is 55. And I'm going to also have to multiply that by 2. Okay, so then I'm going to have to do 66 times 2, which is 132. And then 30 times 2, which is 60. And then I'm going to have to do 55 times 2, which is 110. And if I add all of those together, I end up with 214 centimeters squared, because we're still talking area. Okay, so we're still trying to find that area for it. And I just realized I messed that up. Okay, we ended up, we had our 60 here and our 110, but our final area should be 302. Sorry for those of you who maybe caught it before I did. Okay, 302 for the surface area. I just added wrong. All right, next one. As you guys know, the cylinder is kind of a little different here. A little unique with the surface area. Okay, and so they kind of created a formula for us. So you can just write it down, memorize it if you want. Okay, the 2 times the area of the 2 circles, so the 2 bases, top and bottom. So that's kind of the first part. Then the middle part, if we were to unwrap that middle part, it would actually be a rectangle, which would include the height of the figure. And then this part is actually the circumference of one of the circles. So that's how it kind of came about, is 2 times pi times r is actually the circumference, and then they multiply it by the height to get that middle piece together. So if we're going to be using surface area to find the cylinder, find the area of the cylinder, okay, our surface area formula was 2 times r squared times pi plus 2r pi times h, right? Circumference times height. So then we just plug in what we know. We know the radius is 7. We know the height is 14. So I plug in 7 for my radius for both of them. Please notice that one of them is squared and one of them is times 2, and then times 14. So some of you, I would love it if you kept it in terms of pi. So if we do 7 squared, we get 49, and then times 2, 98 pi for the first part. Then the second part, we end up with 14 times 14. So we have 196 pi. And if we add those two together, we get 294 pi inches squared. Now for those of you who maybe like the decimal a little better, hopefully you got 923.63 inches squared. But terms of pi, I think, is always nicer to look at. All right, finding the surface area of this pyramid. Okay, so notice that I have a square base, which means all of my triangles going up have the same base. So my base is 25 by 25, which is 625 feet squared. And then I have all of these triangles. I'm going to use my slant height of 32 and my base of 25, and I'm going to have to multiply that by 4. Okay, so to find the area of a triangle, 1/2 base times height. So 0.5 times 25 times 32. Okay, we get 400. And then remember, we have to multiply that by 4. So times 4, we end up with 1,600. Okay, so 1,600, and then plus the 625 for the base, we get 2,225 feet squared. Okay, so if this works out for you breaking it up like this, I think that's great. If you have a better way of doing it, I'm not going to stop you, but I need to see some work involved.